So the philosophy of the PS121 education team is that it takes a community to teach a student, and that is so true with our course. We reached out to parent advocacy groups and to the community to tell them about our goal of creating an online course on muscular dystrophy. And they were so enthusiastic that they provided funding to support this cause. So some of our funders include Parent Project Muscular Dystrophy, Limb-Girdle Muscular Dystrophy 2I Foundation, Coalition Duchenne. These are groups and organizations that were started by parents who have children with muscular dystrophy. The University of California Office of the President provided us with an educational grant. UCLA's Office of Instructional Development also supported us in many ways, including with educational grants. And the UCLA Department of Integrative Biology and Physiology also supported this effort. Not only that, there are many experts who gave their time to support the course. And as students, you get to interact with these experts. They are physicians, pathologists, scientists, physician scientists, physical therapists. Members of the community are coming to speak to you. These are families that are affected by muscular dystrophy that have created documentary films to promote awareness about Duchenne muscular dystrophy, and they will be here to talk to you about their passion in advancing treatments and therapies and understanding about Duchenne muscular dystrophy. So I just want to remind you that our online courses are going to appear in the form of mini lectures, and we're doing that for a reason. We found that students learn best in these smaller, bite-sized pieces. Now, when you watch these videos, remember that we're not actors or actresses. We're normal, everyday people. So we may stumble and mispronounce a word here and there, and I hope that you can kind of pardon us. Okay, this course stemmed from not just the financial support and the investment from the community, as well as the expertise from the Center of Duchenne Muscular Dystrophy. And we had funding and support from the entire UC campus. But we also have experts from the Office of Instructional Development who have expertise in directing, producing, editing, in course design. And we've assembled an entire educational team shown here. Our educational team is comprised of Dr. Zaritza Skurik, who is a PhD level scientist, Ethan Eskall, who is an undergraduate at UCLA, who's really given it his all to create beautiful illustrations, and also Ronnie Cho, who's a graduate student here, who's applied his expertise in physiology and muscular dystrophy to the course. All members of the PS121 education team are graduates of the HHMI National Academy's Summer Institutes, which is one of the premier educational workshops that promotes best practices for scientific teaching. So, what do we know about scientific teaching? How do we learn best? Well, in the past decade, there's been so much research to speak to this issue. Experiments done in the classroom have revealed that students learn best when they are involved and engaged in the material. This is supported by experiments from cognitive psychologists as well as research done by neuroscientists. The end result of this decades-long research is that students must be actively engaged in the material in order to really construct new knowledge. And this research has led to national calls for reform from many scientific institutes, from many educational institutes, and including the White House. These calls for reform are asking academic institutes and faculty members and instructors to rethink how they're approaching the classroom and to approach the classroom in a way that best serves the student. So, many of my own personal heroes in this effort include Carl Wyman, a PhD level scientist who won the Nobel Prize in Physics. And after that, he turned his attention to STEM education and to ask the question, how do students best learn science? Joe Handelsman, a professor at Yale University who's currently working in the White House, has also joined this effort and really pioneered STEM educational research. In addition, much of what I've learned about education comes from Dr. Clarissa Dirks, shown here in actively practicing engaged student learning, and she's at the Evergreen State College. So, as I mentioned, there is now a large body of research showing that active learning increases student performance in science, engineering, and mathematics, and that all students, regardless of their preferred method of learning, all students from all backgrounds learn best in active learning. So much so that the retention of the material is retained long after the course is completed, and that this is also reflected in student grades. Using active learning techniques, students usually earn a half a grade higher compared to those who were not exposed to active learning techniques. In fact, many educators are saying that it is now unethical to teach any other way just because this is the best method to promote learning and long-term retention of material. So here is one of the pioneering books, Scientific Teaching, that was written by Joe Handelsman and colleagues. And if you're interested in learning more about scientific teaching, I encourage you to use this as an entry point. So what exactly is scientific teaching? What does it mean to be actively engaged? At the center of scientific teaching is the student. It is not the professor. The student is at the center. And just as an example, here is a traditional classroom. I mean, I'm sure that you've been in these classrooms, right? The professor is standing at the front of the classroom. There's a large lecture hall. If you look in there, you'll see that some students are having lunch, some students are on their phone, some are engrossed in their laptop. There are a couple that are propped up on their elbows, sleeping. This is what we've been calling education, and it is not effective. What has been shown through scientific research to be effective is when the professor is silent. This is the active learning classroom. The students are up at the whiteboard. They're not sitting in a large lecture hall. They're talking and interacting with each other. They're trying to solve problems together. They're teaching each other, this peer-to-peer learning. Here's another example of an active learning classroom. This picture is taken from the University of Minnesota, Minneapolis, where they really pioneered a lot of the active learning mechanisms. And I had a chance to visit last year, and I thoroughly enjoyed it. So you can see that students are talking to each other. They're given an assignment, a difficult problem, and they have to work together and pool their resources in order to solve these problems. So sometimes when we think about active learning, we think about the professor almost being quiet and silent, which is so contrary to our traditional mode of teaching. So let's take a look at this picture. Who is the teacher in this particular diagram? Is it person C who's sitting down engaged in the experiment? Is it person D who ran out of the classroom to get more reagents? Is it person B who's doing the experiment? Or is it person A who's taking notes about the experiment on the chalkboard? Well, in the active learning model, these are all teachers. They're teaching each other and demonstrating to each other a particular scientific concept. The reality is that the professor here is Neil Garg, a professor in the UCLA Department of Chemistry, and he has this really great TED-Ed video that will restore your faith in teaching. The link is here below, and you can watch it if you're interested. I highly recommend it.